Okay, Carl likes the number 17. His favorite polynomials are monic. There's a footnote there. Monic means the coefficient on the leading degree is going to be 1. All right, these are quadratic, so it's going to be x squared problem. It says that intercoefficients, it says one of the roots is 17, and it says the roots, there's going to be two roots of quadratic, differ by no more than 17. You like 17? Compute the sum of the coefficients of Carl's favorite polynomial. Look at the whiteboard. Oh, by the way, this comes from the Stanford math tournament. So let's take a look at it. And let's write this down now. And let me show I got a pen out. Yeah. I'm going to call Carl's polynomial kx. It's a monic quadratic, which means x squared. I don't know the coefficient, but they did say it's integer coefficient, so b and c are integers. All right? They tell me one of the roots is 17. So I'll write this over here. So it's going to be x minus 17, and what goes over here? I don't know the other root, by the way. I'm going to call it r. All right? Now, certainly r is an integer. It's an integer coefficient. All right? So what do you get over here? Well, let me multiply it out. You're going to get x squared, and then you're going to get, let's see, minus, I'm going to say 17 plus r times x, and then plus 17r. Now, by the way, tell me this other root, the difference between those two can't exceed 17 in either direction. So I'm going to write down two different ones. So minus 17, and these roots can't differ by more than 17. So that means 17 minus r, or you could write down this one. Now they both lead, you can try that out by the way, they both lead to r being between 0 and 34. Right? How do you do that? Add 17 to both sides or subtract 17 from both sides. You get that, all right? So I got a problem now. They want to know the sum of the coefficients, and I'm looking at these things. I know what the coefficients are. They're 1, it's right there. This guy's coefficient, that one, and that's the third coefficient, by the way. And the way I'm going to do that is evaluate Carl's polynomial at 1, and you get something pretty simple. You get the first coefficient, you'll get the second coefficient, and you'll get the third coefficient if I evaluate x at 1. And what does this give me? There's the sum of the coefficients for you. And you're going to get, let's see, 17r minus r, 16r. And minus 17 plus 1 is minus 16. All right? But the r's vary from 0 to 34. So I'm left with the sum now. And that's going to be r equals 0 up to 34 of 16r minus 16. I'm going to factor out a 16. R equals 0 to 34. And then I get R minus 1. Now it's an arithmetic. And arithmetics are pretty easy to sum together. But I still want to go through it. And what's that going to be? That's going to be 16. And let's write this down now. If I start at 0, I get minus 1. Then I go to 1. That's going to be 0. And then I'm going to go to 2. That's going to be 1 plus 2 plus 3, yada, yada, yada. And I'm going to stop at 34 minus 1, which is 33. All right? This is going to be 16 minus 1. I'm not going to put that down. But I know how to sum the integers from 1 to 33. That's going to be plus 33, 34. That's n plus 1 over 2, by the way. All right, let's keep doing it. When you get over here, 16 minus 1 plus 33. 34 divided by 2 is 17. All right, yes, you're expected to do the arithmetic, by the way. You're going to get 16 minus 1. 10 times 33 is 330. And let's see, plus 7 times 33, that's 210 and 21. So that's going to be 231. All right, let's keep going. 16, that's going to be 330 and 230, which is 560. Wow. Let's see if we can do that arithmetic over here. That's 5,600. That's 10 times that. Now let's do 6 times that. It's going to be 0, 36, 33. Let's see, 0. I think I made a mistake there. Let me just do it again. 6 times 0, oh, it's 36. And 3 on my head. Let me just check it again. 6, 36. Yeah, I think I did okay. That's 8960. Final answer. 8960. Thank you.